everyone. Welcome to the study of basic trigonometric identities. You are going to evaluate theta when you are given 5 cos squared theta plus 2, which is equal to 3 sin squared theta minus 2 cos theta. And the range which you are given is that the theta lies between 0 to 360 degrees. So theta lies between 0 degrees to 360 degrees. Now, we are going to make use of this identity, which the basic trigonometric identity, which tells us that cos squared theta plus sin squared theta is equal to 1. Then we can take cos squared theta the other side, so that we have sin squared theta is equal to 1. So where we have sin squared theta, we substitute with the 1 minus cos squared theta, as indicated here on the right hand side. Then we remove the bracket by multiplying. We remove the bracket by multiplying. 3 times 1 is 3. 3 times negative cos squared theta will be negative 3 cos squared theta minus 2 cos theta. Then we group the like term together. 5 cos theta squared plus 3 cos theta squared will result into 8 cos theta squared. Plus, we take this negative 2 cos theta on the left hand side to have 2 cos theta. Then you have 3, we take 3 on the left hand side, so that you have negative 3 plus 2, which is negative 1. At this juncture, 8 cos theta. Now we can write this part 2 cos theta in terms of 4 cos theta minus 2 cos theta, because it is the same. Now this is a quadratic equation which we can factorize by pairing. We pair the first 2 and the last 2, so that you obtain the following. So you can factorize this by pairing. Here we have 4 cos theta, which is common, so we factor outside the 4 cos theta, so that you'll be left here with the 2 cos theta. Here we will be left with the 1. Then in the last part, the common factor is in this part here. What is common here is negative 1. So when we factor negative 1, we will be left with the 2 cos theta plus 1. This negative and the negative first sign will make this negative become positive, which is equal to 0. So when we check in the bracket, we have 2 cos theta plus 1, which is common, meaning that we can again factor out 2 cos theta plus 1. When we do that, then we are going to obtain the following. So factoring out 2 cos theta plus 1, here we are going to be left with the 4 cos theta and the other part minus 1, which is equal to 0, meaning that 2 cos theta plus 1 is equal to 0, or 4 cos theta minus 1 is equal to 0. So it implies that 2 cos theta plus 1 is equal to 0, or 4 cos theta minus 1 is equal to 0. Meaning that when you take 1, the other side it will become negative, and you divide by 2, you are going to be left with the cos theta. Or cos theta is equal to 1 over 4. Then from there, now you obtain cos inverse both sides. Then from there, you obtain cos inverse both sides. We obtain cos inverse both sides of this part here. And when we do that, we are going to obtain the following result, and also cos inverse of 1 over 4. So the cos inverse of negative 1 over 2 is 120. And now, because the range is from 0 to, so we are going to have 120 degrees. Because the range is from 0 to 360, the other part where cos is negative, it is in the third quadrant. So 240 is also our answer. Now, when you obtain cos inverse of 1 over 4, then the result will be 75.52 degrees, because now our value is also in the fourth quadrant. We obtain also the following. We are going to obtain 284.48 connect it to two decimal places. Because cos is positive on the for the quadrant, so it is 360 minus 75. This case here, cos is negative for the second quadrant and on the third quadrant. So those are the solution of our given trigonometric following those simple method steps. I hope this video was useful for you. Thanks so much for taking your time to learn with me. For more such learning, kindly tune on to my YouTube channel so that we may learn together on how to solve a quadratic trigonometric function using these simple method steps as I have shown you in this learning. Thanks so much. See you in the next presentation as we keep on learning this important field of maths.